Okay, question number 21 says a particle of mass 1.6 kgs rests on a horizontal table. 1.6 kg rests on a horizontal table and is attached to one end of light inextensible string, passes over a small smooth pulley P fixed at the edge of the table. The other end of the string is attached to the particle B of mass 2.4 kgs, hangs freely below the pulley. The system is released from rest with the string taut with B at the height of 0.5 meters above the ground. As shown in the diagram, the subsequent motion A does not reach P before B reaches the ground. That means it is long enough that it is not touching the pulley P. First part says given that the table is smooth, find the time taken by B to reach the ground. So for the first case we need to calculate the acceleration and movement to calculate the time. So question number 21, if I write the equations for both of these, this is particle A, over the pulley hangs particle B that is moving down due to its weight, tension is upwards. A is moving towards the right hand side and there is no friction, nothing, because the table is smooth. This is A and this is B. So for A, equation would be net force F is equals to MA. This is only the tension is equals to mass is given, that is 1.6 of A. So for B, F equals MA net force. Now downward force is weight minus tension is equals to mass is given, that is 2.4 into acceleration. So if I may just substitute this in the other equation. Now weight is 2.4 into 10, 24, minus tension is 1.6. A is equals to 2.4. 24 is equals to 2.4 plus 1.6 would give me 4 A. So, and acceleration comes out to be 6 meters per second square. Now I have the acceleration and I have the displacement, which is given in the diagram 0.5. So B would reach, that is S is equals to ut plus half at square. Displacement is given 0.5. Initial velocity is 0, it is at rest, plus half, and acceleration is 6 and t square. So we can find the time it takes B to reach the ground. So 0.5 is equals to 3t square. 0.5 by 3 is equals to t square. T square is equals to 0.5 divided by 3 is 1 by 6, and square root both sides. Time is 0.408 0.408 seconds. The second part would say, given instead that the table is rough and the coefficient of friction between A and the table is 3 by 8. Find the total distance traveled by A. You may assume that A does not reach the pulley. 7 mark question. So now we have friction and I'll add one more force. B was going down due to its weight, tension is upwards, tension is pulling A to right, and friction, which is mu r, will pull it to left hand side. So again for A, F equals MA, the equation would be forward tension minus mu r is equals to MA, and for B, F is equals to MA, it is weight minus tension is equals to MA. Now let us fill in the values. Tension minus mu is given, that is 3 by 8, and R is normal contact force, this is 1.6 kgs, makes it 16 Newton. So R is equals to 16 newtons is equals to mass is 1.6 A. On the other side, weight is 24 minus tension unknown, mass is 2.4 and A. So I'm solving for acceleration. 8 1 times, 2 times, 3 2 times is 6. T minus 6 is equals to 1.6 A. T is equals to 1.6 A plus 6. Now we'll substitute it in the other equation. 24 minus t is equals to 2.4a. So 24 minus 1.6a plus 6 is equals to 2.4a. 24 minus 1.6a minus 6 is equals to 2.4a. This goes on the other side, gets added with it, makes it 4a. 24 minus 6 is 18, and acceleration is 18 by 4, that is 4.5 meters per second square. Now we have the acceleration. The particle A and B are accelerating with this much magnitude. Now B would reach the ground, that is 0.5. So on this, at the same time, when B reaches the ground traveling 0.5 meters, A would have also traveled 0.5 meters. The demand of question was given instead that the table is rough and the coefficient of friction between A and the table is this. Find the distance traveled by A. So this is the distance A already traveled when it was connected to B. Now B is on the ground and A would move due to its speed. So if I use the equation v square minus u square is equals to 2as to find the speed of A at this point. Initially it was 0 and finally, so v square minus initial is 0 to acceleration is 4.5 and displacement is 0.5. So v square is equals to 2 into 4.5 into 0.5, getting 4.5, and velocity is square root of 4.5 gives me 2.121. Now this is the velocity meters per second which is at this point, and A would move with this velocity and ultimately come to rest due to the frictional forces. Now we have this condition. A is at this point with a velocity of 2.121 and is moving towards this side. And if I apply F equals ma, now forward force, there's no tension, there's nothing attached, is 0, minus reversive forces mu r is equals to mass is 1.6, and acceleration now is again changed, unknown. That was the previous acceleration which was due to the pulling of the tension. Mu is given 3 by 8, r is 16, is equals to 1.6 a. So we can find a. 8 1 times 8 2 times is 6 by 1.6, and acceleration is, I forgot the negative sign because it is retarding. 6 divided by 1.6 gives me 15 by 4, that is 3.75 meters per second square. So basically negative acceleration, or we can say retardation. I now have this value. I have the initial speed which is 2.121, and I can find the distance traveled. V square minus u square is equals to 2as. Now final velocity when A will eventually come to rest will be 0. Initial velocity for this case is 2.121 and v square is already 4.5. I'm using that exact value. So 4.5 is equals to 2, acceleration is negative 3.75, and displacement to be found. So minus 4.5 by 3.75 into 2 is 7.5, negative 7.5 equals displacement. 4.5 by 7.5 is 3 by 5, that is 0.6 meters. So basically A first traveled 0.5 and it was connected with B, and is now traveling 0.6 meters before it comes to rest. So the total displacement is 0.5 plus 0.6 equals 1.1 meters.